All right, good morning, everybody. Thank you so much for joining us for the Metadata Workshop. I do want to do a little PSA right up front. On the Schedule link, there is a shared Google Doc. If you could please log your attendance and write any comments or notes that you have in there, that would be awesome. I'm going to be really short and sweet because we've got a lot of people here to talk and probably a whole lot of questions. First, I want to be a little forthright and also apologize to folks. This is going to be very wonky in the weeds for NASA EOSDIS folks. This is our metadata workshop. We're going to be talking about the NASA metadata curation tool developments that we've got, as well as some of our metadata schema evolutions and developments. If you're not NASA provider, this might be a little in the weeds for you or not applicable, and I apologize for that. For everyone else, thank you so much for coming. Without further ado, I'm going to make the most of our tight timeline and hand it over to Tyler Stevens, who is our metadata tool guru here.
All right, let me see if I can get back to this presentation real quick and make sure this works, because this is a Mac and I'm a PC person. Oh, I'm so sorry. Did we? Oh, you're good. Okay, I'm not sure what to do. Sorry.
I am so sorry.
No. Thank you. That work? Okay, so I'm gonna make sure the okay. All right, I think we're good now. Well, good morning, everyone. Thank you for, as Valerie mentioned, coming to the Metadata Workshop. For anyone who doesn't know me, I am Tyler Stevens. I'm with KBR on the EED program. I am the product owner of the metadata team, also longtime metadata and GCMD keyword guru. So today I am going to talk about our metadata management tool, because we have a new release coming just a few short weeks. So for anyone who doesn't know, I'm going to kind of give a brief intro to the MMT, what it does, how it benefits our DAX and metadata curators, talk a little bit about the new functionality and the new React MMT that we built in Earth Data Cloud, and also remind the DAC folks who are in the room, and I see several of those here, where we kicked off a couple weeks ago testing, and we're getting a lot of great feedback, fixing a lot of bugs, and crossed our fingers. We are releasing this thing, and just like I said, I mentioned, in a few short weeks. And talk a little bit about some of the future roadmap work on the horizon, and then I will try the best to switch over to do a demo for my laptop, because I have to go on the NASA VPN because it's still behind a firewall until we release it publicly. So yes, for folks who don't know, the metadata management tool is the NASA EOSDIS enterprise web-based metadata authoring tool, and allows the DAX to curate metadata for all the concepts that we manage within CMR. That's collections, services, tools, variables. So the metadata management tool allows the users to manage their records, submit their drafts, update records, delete records, do associations between the different concept types, and be able to access those records. So part of that is, the goal of this tool, as part of the overall goal of CMR, is to promote high quality metadata that can be used for search and discovery, leading to improved utilization of EOSDIS data by all the end users. So I want to show some of the cool functionality that we built into the new React MMT that will help, we hope will help promote some of the high quality metadata. As I mentioned, the metadata authors, curators, and also there is some functionality in the metadata management tool that is used to manage other components, like order options and permissions and such, which I will highlight briefly. So in terms of the data flow, right, data comes down from NASA satellites. That's all archived, and once a DAC is ready to distribute their data, they need to ingest granules, ingest metadata. So that's where the MMT comes in. That for the DACs who do use MMT, that's their main tool to ingest collections in CMR. Obviously, also we have several providers who use other tools as well as ingest scripts and other methods to ingest their collection and other metadata concepts into the CMR. But this is just a general overview of the flow. Looking at my time here. All right, so just a couple of the highlights from the current MMT, which is an on-prem tool written in Rails code over 10 years ago, I believe. We moved that from on-premises to the cloud. So it was just an Earth Data Cloud. We use AWS for that. And it's built primarily in React. We also removed the need for a database, so we fully utilized all the CMR functionality in AWS infrastructure using S3 for templates and GraphQL for fetching of information to help improve performance of the tool. So I think a lot of users are going to notice when they use MMT now, it's a lot more performant, and we're really hopeful that that's going to be a great benefit to users. So we also removed this convoluted provider context. It's hard to explain here in a bullet, but we'll try to show that a little bit in the demo. Totally redesign the application to prepare for other feature developments at deduplication and just overall user experience, going from a horizontal navigation to a left-hand navigation to accommodate new pieces of functionality in the future. And I already mentioned about the functionality to associate any concept. We had to actually change that functionality in the CMR to handle that, but the MMT also supports that as well. And I already mentioned the GraphQL functionality. This is the high level, techie architecture diagram. I come from the science side, so I'm not too much into the technical weeds of this, but we use Node.js, React, and serverless framework. The metadata concepts are supported via a JSON schema, and that form is generated in MMT using JSON schema form. I already mentioned we use Amazon S3 for storing templates, CloudFront for distributing the static content from S3, GraphQL, and login to the MMT is through Launchpad. I'm going to give a brief demo here in a moment, but just wanted to highlight some of the main UI UX improvements. I already mentioned left-hand navigation, so you can see there over here. Previously, when the current MMT, all those concepts were horizontal on the top. So now you'll go into the tool, into our UI environment, and see collections, variable services, tools. All those options are all on left-hand navigation. We changed the provider context, and also login is down at the bottom left. This is to kind of align with some of the other current modern UI UX standards. Logging in, being able to see your providers, get to the metadata user guide, which we're going to update for the new React MMT. We haven't yet. We're working on it. And I mentioned user testing and feedback. We've been developing this for over a year, and we have a target date in about 3 weeks to release this to production. So a few weeks ago, we asked the DACs and the providers who use MMT to go in and just hit it hard in UAT. So we've gotten a lot of great feedback from the DACs. A lot of people here in this room I know I've talked to, Slacked, emailed, written JIRA tickets, and we are working on those bugs. A few bugs were more critical than others, but we're continuing to triage and resolve those as quickly as possible. So for anyone who hasn't tested yet, we're encouraging that feedback. Please reach out to me directly, support, email, Slack, hunt me down here at ESUP this week. I'm looking forward to talking with other folks who have questions about MMT. And whether here, I will also be at the Research Showcase tonight, and I'll be here through Friday midday. So please come find me if you have questions about MMT when you've been testing. Looking at the future roadmap of MMT and our metadata schemas in general. So as I mentioned, we are getting ready to deploy MMT React to prod currently scheduled for the week of August 12th. We have our EOSDIS review gate. That's an internal thing, I know, but just kind of making sure all the checks and balances are in place before we officially put the rubber stamp on it and put it out there in prod. Some things we're looking to as part of this overall app deduplication. This may have been discussed, maybe it's some other session this week, I'm not sure. We have a separate application, the curation dashboard. That's primarily used for QA reporting and allowing DAX to have a manual review and also automated review of the metadata to improve the overall quality. And there's an API behind that, PyQuark, which is used. So we're looking to, at some point, to integrate critical pieces of that functionality directly into the MMT. Also, we have, let's just hit here, DMMT. This is the Draft Metadata Management Tool. We do have providers outside of NASA and EOSDIS who contribute metadata to the CMR. We have obligations and partners within other organizations like CO, SWIGIS, and other international partners and US partners that contribute metadata, but don't have NASA PIV carve access. So the way that tool works is that a user will submit a draft, someone on the inside, myself and some of the other science team members on the program, will review those records and ingest those records into the CMR because we have the appropriate permissions to do that. And following that, the focus, at least for the short to midterm, is just once we release this to prod, to sustain and engineering, fixing vulnerabilities and any operational bugs that come up. The metadata roadmap, I'm not going to talk too much about this, but we're going to have a metadata panel here in a few minutes to kind of talk about some of the evolution of the models. We have UMMC. There's going to be some changes coming up to that for dataset landed pages, UMM-VAR for variable first services, UMM-VIS to support some of the use cases from Worldview and Gibbs. And this other, right now we're still calling a generic metadata model. This is for suborbital, KC, and airborne. And then corresponding documentation updates for that as well. All right, I'm going to try to switch real quick. See if I can do this quick little demo here. All right, so I'm going to see if I can do this real quick. Let's see if this works. All right, I don't have a lot of time, so I'm just going to give a very quick demo here. And as I mentioned, if there's time at the end, I can give a more in-depth demo. But I'll also be available tonight at the Research and Demo Showcase to give a more in-depth demo of the tool. So I'm logged in. I'm sharing correctly, right? Okay, good. Thank you. So as I mentioned, this is the MMT tool. This is the new React application in UAT. And just to kind of highlight a few things, right as I mentioned, we have this left-hand navigation. So these are collapsible. So you have collections here. So you can manage your collections, templates, permission. If I'm interested in tools, go down here to tools and be able to see all of the tools that I have access to. This is in the UAT environment, so this is not production data. Other things, so in the current Rails MMT, we had a lot of functionality kind of buried behind this CMR section, order options, permissions, and groups. Some things we did not bring that functionality over to the React MMT because it was hardly used, mostly used to the CMR API. So some of the things we did bring over was order options and groups. So you can manage all your order options and your groups, collections, permissions, things like that here as well. But let me go over here real quickly. So if I want to create a new collection draft, I go over here, create new draft. And one thing I just want to highlight here is you'll notice here on the right-hand side, this is a brand new record. So this kind of here is showing me all the information that I need to provide. So once I start adding information here, especially to the required fields, you'll see the validation over on the right kind of minimized because I've already gone through and added that. So once I go through and populate a record, or at least this section here, that narrows down. I don't have time to go through that at the moment, but I do want to mention when you click through each of the sections here, you'll notice those immediately come up. Previously in the Rails MMT, the page refresh had to happen every time, so it took a lot longer, especially if you had large records. But this is really fast, and the technology to use that. Oops, got something here right now. To just load all that up and everything. Something happened here. So yeah, and then once I have a record that I want to publish, I can go over here, I can save, publish, or preview. And at this point, this will prompt me to save the record in a provider. These are all the providers I have access to. I'm special, so I have access to a lot of providers. So I am just going to, oh look, Val Test. I wonder who that is. Well, there you go. I found a bug. Doesn't like Val Test. This is great of a live demo. So I think that's my cue to stop my demo. Yeah, I don't know what happened there, but yeah, like I said, we'll have time later or at the research showcase night to go through. Oops, sorry, I'm trying to find the screen to unshare. I don't want to take up some of the other presenters today, so I'm going to end that there and just open up to a few questions for now. And let's try to, we have the, yeah, and then I'll repeat it in the, thank you. Repeat that here. How do we go back to the,
Yeah, I was just curious how long it took you to make that migration with the new React application. Like how long to build it?
so we've been building it in pieces for well over a year now. Including the, each of the different forms. We had to kind of build all that from scratch. Yeah, well, a year, but we're ready to put that out there to the world.
Hello, Tyler. This is John Fan from JPL. I'm online. Can you hear me?
Yes.
Oh yeah, I have two questions. The first one, in the tool, I don't see UMMG. Is that handled somewhere? Or...
So UMG, that's granules. Right. So we do have granule metadata concepts, but those are not managed through MMT. They weren't in the Rails MMT. They're not. They're so large and so extrapolated that users generally just generate their granules and ingest via the CMR API. So we don't have a tool to manually curate granule metadata.
I see. And eventually, will UMVs also be there? Or
Eventually, we will be adding the other concepts. Granules were intentionally left out of the MMT because granules are so numerous that the vast majority of our providers don't do them onesie manual.
Yeah, the other one, is there any tool to help the schema designer to do, or just basically just pretty much assume the schema is already there and just the provider just use that?
I didn't quite catch the question.
Yeah,
I'm sorry. Could you restate the question?
Oh, okay. What do you use for the schema design?
We use JSON. Like the schema is written in all the schemas are written and supported in JSON. JSON 7 is the most recent version that we use, and then from there the MMT React app will build the forms based on the schema.
I see. You assume schema is already there. So.
Right. Yeah. You have to have it in the. You have to have the the concept in the validation JSON schema for the form to be generated in MMT. So yeah, so once we have Viz or other concepts in the future, and we want to put those in MMT, then it's not too much of a lift to add those new concepts. We kind of make that flexible in the new React MMT to be able to very quickly generate that JSON form for a new concept, or even when we have updates to existing concepts like UMMC or UMMT or whatnot, it doesn't take a huge lift at all to update the form to accommodate like a new field or a new enum or whatever new thing we added to that model.
Sure, thank you.
And I think maybe just one more question, then we'll go on, and then at the end we can have more discussion.
I kind of have two questions.
Okay, yep.
EOSDIS has done a bit of testing in the new MMT UAT environment, and just wondering about progress on the ability to clone records to create a new record, and also on the groups in MMT for the ability to update access control lists.
Yeah, so the clone issue is fixed in SIT, and I believe if that hasn't gone to UAT, it's going to go to UAT during our next deployment, which will be next week. I'll check on that for you. And the other one, I believe we're working that issue right now. We do have a ticket for both of those.
Just hoping those are ready to go on that August 12th.
Yeah, and right, like we have a cadence of two-week deployments, but right before we release, we will make sure we push all the updates out for that before that public release. So maybe we can go on, and then we can have other questions at the end. I don't want to move on. Yeah, we're gonna have.
All right. So do we have those slides up?
I don't know what folder they went into. I have Cheyenne come up. And I think. Oh, you do? I'm sorry.
No, you're fine.
Curation dashboard or ARC, right? Yours is the ARC one, right?
Yes.
Okay, that's what I thought. Okay.
Good morning, everybody. My name is Cheyenne Kirkland, and I'll be giving a presentation on the CMR Metadata Curation Dashboard. If anybody knew Jenny, I recently took over her position as the ARC team lead. We are under the Impact program, and I work for the University of Alabama in Huntsville. We are also partnered with Marshall Space Flight Center. So just to kind of do a really brief overview of what we do, ARC stands for the Advanced Review of the CMR, and we conduct detailed quality assessments with an emphasis on correctness, completeness, and consistency of EOSDIS metadata records within NASA's CMR. We do this to help improve the discovery, access, and use of NASA's Earth science data within Earth Data Search. There in the bottom left corner, I do have our assessment process. We'll go into a little bit of a deeper dive into that. But there in the bottom right corner is how we conduct our metadata assessments. We rank them based on priority, whether it's high, medium, or low. High priority assessments are things like broken URLs, maybe inconsistencies between collection and granular relationships. Medium priorities are maybe revisions of existing content or the addition of new information. And then finally, our low priorities are minor consistency issues. Also, just really wanted to throw PyQuark out there very quickly. We are over PyQuark, and this is a customizable open source Python library, which basically automates our job as much as possible by completing those basic validation checks and finding those inconsistencies and identifying new opportunities for more descriptive information PyQuark is still in the beta phase, but hopefully we will be doing a full release coming up. And PyQuark, within our last round of testing, flagged about 74% of metadata findings, and we are continually working on PyQuark. So this is the CMR metadata creation dashboard. This is how we go in and do our assessments. Initially, metadata reports were shared with DACs using spreadsheets. Fortunately, this was before I started, but this tool is extremely useful, and it also allows us to share our metadata reports directly with the DACs. So first I'll go over our ARC Curator dashboard, including the review process and some features. So starting out, this is what the homepage of the CMR dashboard looks like. We ingest the record. We then enter our search criteria, which is usually a concept ID, but we can also filter by DAC or campaigns and projects. We select our record, and then we can begin our review. I did want to point out a new feature, which is the format column there next to the concept ID. This is very useful to us as it shows us the metadata schema from the dashboard homepage. And it's very useful when we do our PyQuark testing because PyQuark does require that we input our metadata schema. So once we begin our review detail, we go in and associate the granule with the collection. And another feature that we have is being able to delete the collection from that record page. Originally, it was just available on the CMR dashboard homepage, but now we also have this functionality here. So it is a little bit more accessible to do that. This is what it looks like once you go in and you can see all of the metadata elements. A feature we've also had is to copy prior recommendations, which brings in recommendations from previous reviews that we've done, and this ultimately helps with consistency. This is what it looks like once we go in and do a review. As you can see, we do have a recommendation here to adjust a platform type based on the GCMD keyword entry. But as you can see, this is how we flag our records, include our recommendation, and then we also can add that color as well to indicate the priority. Another new feature within the dashboard is posted discussions or not higher up. So the bottom, we have a discussion and justification, the justification section. And this is how the ARC curators can go in and kind of communicate with ourselves between records. We usually have 2 to 3 reviews, so we're able to leave comments for each other. And this, the new feature is that our posted discussions are now above the new comment section, so those discussions are easier for us to catch. Another feature is that second opinion flag, which brings attention to those elements for second and third reviewers. It also flags the elements on the metadata elements page, so it makes it easier to see. Another feature is that PyQuark, the PyQuark output is actually visible within our dashboard. This is beneficial because output is more accessible during reviews. We do not have to run any kind of code to access PyQuark output. And it also serves as a convenient extra reference when we are going through and completing our manual reviews. Finally, once we are done with our record assessment, we can go in and release these findings to the DAC. We can release records when a minimum of 2 reviews are submitted. And like I said, DACs will then be able to go into their dashboard and they can see all the recommendations that we made, along with that color coding. There's also a legend that is provided in the CMR dashboard, as well as the DAC Curator dashboard. And this just helps explain that kind of higher level overview. And like I said, you can see where that second opinion was flagged under the acquisition information. And there are certain other things as well, whether PyQuark flags it, or feedback is requested. All that is also visible here within the dashboard homepage. So next is the DAC Curator dashboard. So we'll kind of take a look at what DACs can see post-review, as well as some of the features they have as well. So the DAC Curator dashboard is very similar to the ARC dashboard. They can enter their own search criteria. Once again, more than likely a concept ID, but they can filter by campaign or project, as well as the recommendation color. They will then select their record, and then they can go in and see the review detail. A new feature, it's kind of hard to see, but up there in that top portion, that bar, there's a user's guide button, and I believe this was a newer addition within the DAC Curator dashboard, just making our user documentation a little bit more available. Next is they currently have the feature to edit the collection in MMT, which is currently directly linked to the curation dashboard. But DACs can also go in and see the collection review details and the granular review details. It's also important to note that the MMT option is currently only available if the Earth Data username is the same as what you use to edit your records in MMT. So once again, dashboard is very similar. This is how it looks to a DAC curator, and there on the right-hand side, DACs can see where ARC's recommendations were, as well as that color. One benefit too of going in and doing the detailed review is DACs can also keep track of their progress by using their discussion section there in the bottom. I don't believe that's available to ARC curators to see, but like I said, that is a very good way for DACs to kind of go in and say, hey, I adjusted this element, or hey, go back and maybe reach out to ARC about this. DACs can then close a record, and this helps to indicate that ARC's findings have been addressed and that the metadata has been updated within CMR. And DACs can also close a record as well from the CMR homepage. I believe they may also have the option this way to close multiple records at once. But once again, this just shows that, hey, this record has been updated. There's also a really handy feature called Get Review Report, and this is a button there on next to the C Review Detail and Close, also there on the CMR dashboard homepage. And this is really handy because metrics are included for either your one chosen metadata record, or you can select multiple. The review report can be exported as a PDF or CSV file, and recommendations are listed in order of priority within the dashboard and the PDF. So your red recommendations show up first, then yellow, then blue. Also, it only shows fields that are marked blue, yellow, or red within the dashboard and PDF. If you do the CSV download option, then I believe it also shows your green and your gray fields, but a perk of using CSV is that you can filter and modify your view. I did include some additional resources here, including some documentation, our dashboard, there was a paper, and then the PyQuark and Quark links as well. And that is all that I have. I think we have time for maybe a couple questions if anybody has any.
Hi, M&T newbie question. I'm wondering if there's any logic to running that PyQuark tool in an automated fashion where it's continually delivering reports on new records that are coming in?
I do believe that would be a really handy feature, and I think that would be really useful because I believe ARC over the next year are probably going to wind down our manual reviews and really focus on PyQuark within the DACs. But I do believe that would be a really good feature to have.
Yeah, I was gonna say, we have been thinking about that as Cheyenne mentioned, that things are gonna come back over to the CMR MMT, and probably some way to build that directly in MMT. So once work gets suggested, they get a real-time report out of that. So that's already on our radar.
Any other questions? Go ahead online.
Can a different schema be used? Can a different schema be used behind the scenes? Metadata schema.
So I believe there's the UMMC schemas, UMMG, diff10. I might be missing one. I think there's an ISO schema as well. So we review all of those metadata schemas.
How do you stay up to date on like UMMC schema updates? Like if a new field is added, are you updating sort of your recommendations And how are you making those recommendations?
Yeah, so I believe there are schema requirements that are also included within the dashboard, so we can see them there. With PyQuark, anytime there's a schema update, we also take that update and put it into PyQuark as well, so that way our automated code is updated.
There are no other questions or comments online. We are a little bit behind schedule. So thank you so very much for coming and talking about the Creation Dashboard.
Yes, thank you.
All right, I have to try to welcome, I think Morgan Silverman, are you up next for the,
She's online.
are you online suborbital? All right, I think, Morgan, you may need to try to share screen. Are you there? Can you hear us?
Yes, can you hear me?
Yes, loud and clear.
Do you want me to share or you?
If you can share, I think that would help. We're having a little bit of a technical
Okay.
snafu.
All right, give me just a minute.
Thank you.
Sorry, I wasn't quite prepared to share.
Oh, yeah. If you can tell me which presentation it is in here, I can pull it up too.
Yeah, it's the soot, the one's metadata soot.
I'm not seeing it up on the Google here. Do you see it?
I can-
It should be here though, right? This folder. All right, so it's not the var, it's not the viz. Am I missing it? Am I just not seeing it? Okay.
should-
All right. I'm not sure where to even look for that. Do you know? This one.
Is it not, is your,
Is it the,
It's in the folder, ESIT metadata panel soot.
refresh the page? Okay, yeah, we're trying to see if it's,
is it the second one? Okay.
Yeah,
Oh,
I'm
there
sorry.
it is, there it is. Okay. Thank you. I am impaired.
Sorry
Right.
about that.
So now I just have to figure out how to reshare the screen. Bear with me, I'm so sorry.
that right there, I think.
Yep, I'm not sure how to make
Hit
it,
share.
I'm not sure how to make it a presentation size though.
Download the document.
Well, I was gonna say I could just
Oh, was that not-
scroll.
Maybe that wasn't downloaded, or did we miss it?
Yeah, it's not downloaded.
Okay.
Okay. I could just scroll.
If you can, because I don't know how to download it.
This is fine, I can talk to it.
Morgan, okay, and I'll advance when you, let me know when to scroll down.
Okay, thanks. Hi, everyone. I'm Morgan Silverman. I'm an atmospheric scientist turned part-time data scientist from NASA Langley. I'm sorry I couldn't be there today. Next slide. So I'm going to briefly discuss the suborbital data that we have at the Atmospheric Science Data Center. So as of today, we have over 30 suborbital campaigns that are publicly available at the ASDC. And the majority of these data sets are atmospheric composition focused. So if you're not familiar with suborbital field campaigns, they typically involve a combination of aircraft, ship, ground, sondes, and or mobile measurements. And they can involve both in situ and remote sensing measurements as part of these platforms. So due to the high volume of different platforms and instruments and types of data that you have within these field campaigns, as well as between different field campaigns, it makes suborbital data highly heterogeneous. And then with this heterogeneity comes additional required metadata that is beyond what is currently required in CMR. So our audience is largely science team members and collaborators different research scientists or students and postdocs. Next slide. Oh, next slide. Sorry. So I'm going to quickly go over some of our use cases that we deal with. So the first one is for an atmospheric researcher who's unfamiliar with the names, locations, dates of these field campaigns. What they want to do is find data over the Chicago area. And so they want to do this by drawing a map over or drawing a box over a map so they can find out what field campaigns and variables, if any, occurred over that Chicago region. Next slide. So our second use case involves a more experienced atmospheric researcher or a subject matter expert. And in this case, they're looking to assess the influence of regional transport from mainland China over the Korean Peninsula during the 2016 Chorus AQ field campaign. So this researcher knows exactly what they're looking for. And they want to download all the granules from Chorus AQ that contain specifically CO, CO2, water vapor measurements from the DLH instrument aboard the DC-8 aircraft, as well as the aircraft's navigation and meteorology data. So very different use case. Next slide. The third use case also involves an experienced atmospheric researcher, but in this case, the researcher is looking for older data sets of ozone so that they can assess globally changing ozone from the 80s or 90s. And so they want to find these data sets, but they don't know exactly where they have occurred. So they just need to basically search for ozone data and then see what's available. The next slide. So the last use case is a little different. This one involves ensuring data that users are finding all data that's available. So in this case, the user is looking to download TracerIQ field campaign data, and they need to find all the related data sets, which includes ground networks such as TollNet data. So since TracerIQ and TollNet are both separate missions and collections, somehow the metadata needs to be able to ensure that those data sets are connected so that a user is aware that there's TollNet data when they search for TracerIQ data or vice versa. Next slide. So to better address these use cases, the EOSDIS has developed the Suborbital Order Tool, or SOOT as we call it. And SOOT is a data accession tool designed to promote suborbital research and analysis to complement Earth data search, but to enhance the findability and accessibility of these field campaigns. So the metadata shown on the left here are all the elements that go into our database to make these campaigns findable from a variable level perspective. Next slide. Excuse me. So SOOT is designed to support different approaches to access data, either by selecting a few variables for all flight or all variables for one flight. So the metadata that we have, and I'm sorry, it looks like the figures are blurry, but there is a poster this evening, so if you're interested, please go see the poster. But the metadata data that we have allows SOOT to display by campaign and deployment and platform PI data files, and then in those data files, the variable lists that go with them accordingly. So it also has a merge service that allows you to transform this data into an analysis-ready product. Next slide. So these two images, which also look very blurry, just show that as part of the merge service, you can see each variable level selection that's available from within the data files, all available because of our metadata. Next slide. So then in limited beta release, we've also have this, this, I guess, enhanced user interface, we're calling it, to further elaborate on our use cases to help more directly find the data through variable search filtering. Okay, next slide. Try and wrap up here. Oh, yeah, I'm missing something, but it didn't come through. Let me just talk about it. So the changes that we want to address largely revolve around variable level metadata, which is ongoing as part of the UMMVAR efforts, and I think you'll hear about that a little bit later. So as I mentioned in this last use case, what we've heard termed kind of collections of collections is becoming more prevalent. And we really need to make sure that the needs are being addressed for those issues. The other issue involves transit and ferry data. So a lot of these aircraft fly, cross country or halfway around the world to their final destination for a field campaign. And the issue is how to relate this data, which is equally as important, to the field campaign, which creates a large bounding box. And if that bounding box isn't over just the campaign area, it can be misleading about what the objectives are. And so how do we address this appropriately? And then lastly, we want to make sure that existing variable schema, such as the WMO Integrated Global Observing System metadata schema, are considered. People have already, gone through this, and we don't want to reinvent the wheel just starting from scratch. So make sure we consider everything out there. Next slide. So from the community, we want to ensure that there's ample input from science teams and instrument scientists, not just the opinions of the data scientists, since there's two sides to this puzzle. And then we want to ask the community, how do you use airborne data, and what would enhance your data search and discovery experience, so we can make sure that we have the metadata to better suit your needs. That's it. Thank you.
All right, thank you.
Thank the planning. Everybody's talking about. All right, so.
All right, why don't you set up the next one while I walk through?
Yeah.
Are there any quick questions while we set up the next presentation?
Hi, complete newbie question. I'm wondering if there are any challenges to the metadata from maybe continuous campaigns, sensor campaigns, where you're constantly having to update data and then perhaps even pair it up with older data sets.
Where'd my mouse go?
Were you able to hear the question very clearly?
Not clearly, no.
Are there any complications with, oh man, continuing campaigns? I butchered your question. I'm not sure if you want to come back up and restate it.
Oh, yes, I was asking, do you have any issues with perhaps continuing campaigns where you constantly have to update the metadata and match up that metadata with older campaigns, historical campaigns? Like if you had like remote sensors on every commercial flight in the world, you're constantly pulling in data, but you have to adjust for routes changing or something?
So we do update the metadata. We don't have any cases exactly like that, so I'm not sure how that would work. Our most continuous data would be like a ground network that continually gets updated. But yeah, I guess I'd have to look into that further. I'm not exactly sure how to answer that.
It's not sharing anymore?
I think we need to select the correct screen to share this problem. All right, thank you for your patience. We will be moving on to human viz as soon as we get the sharing right.
Is it sharing?
We're good to go.
All right, Zing, are you going, I can,
Yeah, I'm here.
I can move the slides along. Is everything sharing okay? Okay.
That's fine. And if I can share my screen, I'll be good too. So.
Well, we already have it up. Maybe I can just progress along. You can just let me know and I'll prompt through it.
Oh, sure. Okay, probably it's easier for you. So, all right. My name is John Fenshing. I'm from JPL Gibbs team, and I'm going to report our current work on the uniform meta model for visualization, is simplified as abbreviated as UMVis. And the other members also worked on this, and they are Joe Roberts is also from JPL, and also Ryan Bowler and Angela Lee, both from GSFC. Next slide, please. And to start off, I like to explain why we need this. And we all know CMR is a registry for all the NASA's data collections. And also we know GIPS as a service creates a lot of visualization products from many NASA data. And as a standard WMTS service, GIPS also provide the capability file to describe the layers which is created. However, it does not provide information to understand how that particular visualization associated with the original collection which used to create such a layer. Next slide, please. And also clients like Worldview and EOSDIS Search, they currently independently manage their own metadata in order to satisfy a user need. And also the image, browser image providers, they're currently manually sending their metadata through the for their visualization layers to GIPS. Currently, there's no common metadata service to connect all the missing, all the dots to make the whole entire thing to be across the different service to make it smooth. So, and we think CMR could be the place to capture and also provide such a metadata, make this linkage, bridge over the gap we are observing. Next slide, please. And in the long term, I think the benefits are the following. And if we have UMVets, and will enable robust and easy integration of realization services, and also more consistency of visualization usage across the EOSDIS, and also make the visualization through the CMR as the entry point for users to discover. And also finally, we can enable the data providers to do more efficient browser image generation, as well as to enable them for a much better streamlined onboarding of the new products. Next slide, please. And we currently, we start off with a couple of user cases. And the first use case is to say if a user already know a collection of the variable and how they can discover and find out whether visualization in GIPS it's already produced, they can go to view it. Next slide, please. And this is a visual capture about that kind of a user case. On the left, you have the search, and then the user wants to find out and what's the corresponding GIPS visualization layer is. Next slide, please. And the user case 2, that's the opposite of the first user case. Say for a user already see a layer and how they can find out what's the original collection or the variable is used to generate this visualization layer. And next slide, please. This is a visual capture for that user case. And you already have in the Worldview, and then find an interesting layer and the weathering where I can find the corresponding collection and also download the data. Yeah. Next slide, please. And the third user case is concerning product image, browser image provider directly. And right now, as I mentioned before, the provider each manually to submit their metadata to GIPS for a particular visualization layer they generate. And also the information which is important for scientists to interpret a particular layer, which like what regrading process is used, what's the scale, what the color bar is used, and those information is not captured, and it would be very useful for scientists to interpret. And we think, and UMVS can also help in this case. And particularly two types of metadata would be captured. One is to capture the image processing process. The second one is to capture all the information relating to how a particular data source is visualized. Yeah, next slide, please. And based on those 3 user cases, we set out to design a schema. And when we doing this, we also consider the possibility to be able to make this schema generic enough, which hopefully can help other visualization service other than GIBS WMTS service and its map service. And currently, with this design, it's a 2-level schema. And on the very top, and it's called UMVS schema, which will capture all the metadata type of information, which we assume, and we also expect it to be common to many different type of visualization. And also in this top level, we also have a particular field called visualization type. And it's defined as one of data type in a JSON schema, which when a particular subtype is selected, the schema will choose that particular subtype and load it in all the meta fields related to that particular visualization type. Currently, we already implement and design a schema for tiles type, which directly relates to GIBS OGC WMTS service layers. And also in that top level, another field is called concept IDs, which that's the one we can use to make connections or associations among different concepts, like for UMVS layers, and also collection of granule or some other variable concepts. Next slide, please. And here I just in this block, I listed all the fields name, which I think it's crucial to this top level. And also I use the color red to identify that the particular fields which allow to switch among different subtype. Next slide, please. And now go on to the subtype. We call the visualization type of tiles. And we currently already have tools implemented to be able to generate sample records for those subtype, and we collect all the information from a couple of existing sources, including GIBS WMTS capability document, and also GIBS visualization layer metadata file, and also the worldview configuration metadata for layers. And also there's a few other key fields. It's from the original the visualization metadata concept operation document. The next slide, please. And in this slide, and I have 2 blocks. Each one listed some key metadata information fields. And on the left, it's the one I grouped together, which will represent all the key fields, which will describe what a particular tiles visualization is. And the other one on the right, as it captures all the metadata information about how that visualization is generated from its source data. Next slide, please. And we, with our preliminary tools, and we already create a couple of sample UMVS records, and I put it on to this Git repository. And this is a screenshot of one of the layer which has those UMVS fields shown. Next slide, please. And currently, we already in collaboration with a couple of teams, and we are shooting for the end of this fiscal year with a couple of things accomplished. With CMI team, we tried to establish some test instance and with a sample UMVS record and for selected GIBS WMTS layers, and also with DAX, some DAX, especially PODAC and a Hybrid team, we tried to improve current draft for UMVS schema and to support browser image generation. And lastly, we also started working with GIBS, especially the worldview team, try to prototype some new features using UMVS schema, and also re-implement some features which are already there, and to make the whole thing to be more smooth. Yeah. Next slide. Yeah, that's the end of my talk. I'm open for the questions.
think we may need to hold some questions to the end. I want to apologize for the contextual whiplash here. My eyes are not what they used to be, and I'm running off a tiny agenda on my phone. We're gonna go back to Stephanie Wingo here, who's going to talk to us about the Casey tool a little bit.
I can't get out of this one, okay.
All right, so to file that presentation. We're having some PC Mac interoperability issues here.
Yours is this one. Are we still sharing? Okay, I think all I gotta do is just put it here. Ugh. Why did you do it like that?
All right, I'll try to go through this quickly, 'cause I know we're short on time.
Yeah, I don't know why I put it in.
Oh, is that?
It's a presenter mode. I hit screen.
Hi, folks, I'm Stephanie Wingo. I lead the Airborne Data Management Group, it's part of NASA Impact down in Huntsville, Alabama. We do more than data management, and we do more than airborne stuff, so yeah, scope creep is real. But I want to emphasize again this importance of airborne and field observations. Morgan's talk was especially helpful in setting up some of this context. So this was from the National Academies, essentially back when they were looking at replacing the NASA DC-8 with a more modern aircraft, and making the argument and showing how important these non-satellite observations are for our understanding of Earth systems and the evolution and changes of those systems now, particularly more than in previous times. So as everyone here knows, we've got these observations from decades of NASA's involvement in these field campaigns or field investigations. And the context of those observations is absolutely critical for the appropriate reuse and findability of those data. And there's a lot of challenges in obtaining that context and verifying that context. And one is just that they're spread out over so many disparate sources. And another, now as we're kind of in these modern times, going back with these, I love the legacy data, but getting that context, we have losing institutional memory as folks move on, folks retire, and in some cases folks pass away. So, some of the questions I think Tyler had posed for this is like, who are our audience? Well, we've set up Casey to serve, a wide variety of folks in many different ways. So some of this, I think most of y'all, if you're in EOSDIS world, you hopefully are aware of, but we released our beta flag from Casey last summer. We had developed the data model, which is roughly illustrated in that diagram. We'll come back to that in a minute. And the definitions that we used, which was really a crucial step in putting together the data model, is saying, what do we mean when we say a deployment? What do we mean when we say a campaign? Those definitions were vetted through an ESCO review, and we actually talked a lot about that at the previous ESIT meeting. So, but a key thing is that the metadata within Casey, kind of the topic for the part of the topic for the workshop was the metadata itself for these suborbital and field efforts. Within Casey, in order to really capture that, we've represented those metadata elements at a series of levels throughout each campaign. And there's relationships between those elements at those various levels. And so as we're looking to try to move Casey to a better long-term home within EOSDIS outside of Impact, being able to think through the really big challenge of how do we represent those things is a key challenge. And yeah, so the science users who coming to Casey to find these data, they're oftentimes are interested in a particular kind of event, and it may be part of a particular campaign that they know of or not. And a lot of times we see interest in particular variables. They want to find data from aircraft that have this variable in it. And this ties in really, I think it points to the need to kind of marry these concepts and ideas between Casey itself, which is a little bit broader in an idea, Soot in terms of as a tool for getting to those particular variables a user is after, but then also, and I think Beth hopefully will be able to speak to it maybe in this session on this variables as, variables first, like this all, we're all coming at kind of the same problem. And it really, it's a multi-pronged effort. So Casey itself, you can go there. I won't spend as much time on it, but we've got a lot of content in there from NASA's decades-long history, campaigns, platforms, instruments. We do break down some facility instruments and major airborne instruments. I don't really have time to go through what the specifics on those things are, but the point of this is just showing that we've made a lot of progress, our team, ADMG, in curating the content in Casey, but it's always a moving target, and we are still working to continue that curation and increase the numbers that are there closer to the numbers that we know exist. So some metrics, this was recent. We have noticed over the summer, I will say that like our user numbers have kind of jumped down a little bit. So I guess people are taking vacations and we're seeing that. But we usually are right around or right above about 1,000 consistent users of the tool. And we do metrics on about 2 weeks and then every monthly basis. And we have folks represented across the globe, which is very encouraging. And when we, those users, they actually are engaging with the user interface side of things. We see pretty high user engagement rates. They like going to our Explore pages, which hopefully you'll get a chance to explore. I have a QR code there in a minute, but yeah, so we continue to curate the content that needs to be in there. We've added some really exciting new features. I don't have time to go in now, but if you'd like a demo, I'll be around this evening and happy to show you that, including a really, what I think is pretty swanky timeline on NASA's campaigns history. And really what I'm getting at here and the need for Casey in this metadata conversation is Casey is part of our direct response to the Satellite Needs Working Group first assessment cycle. And so we've put this together within Impact, but really it has it's got legs. It's going to need to keep going and need a longer life. And so we need to push that over and get that really in its more appropriate place. And maybe that means it evolves somewhat to support these other obvious needs in different parts of the airborne community, and help with, maybe we do this as part of a deduplication effort, all of these different needs that are needing to be addressed. But the key thing is representing these multiple levels. We've already gone through and done some mapping analyses between Casey's elements and pieces of CMR and like UMMC, UMMG, et cetera. And we're, underway of some revisions that I think will be for that metadata schema for the suborbital that Tyler alluded to earlier. So just to kind of look, I won't go through every item, but at campaign level, we have all of these specific elements that are pertinent to contextual information about the field campaign itself. We also have that at individual kind of deployment and then subsets of the deployment and intensive operation periods and then significant events. They're key time periods within the deployment. And we have things like spatial bounds at the deployment level and not over the entire length of the campaign. Icebridge, a good example of why we have those broken down and not over the full length of the campaign. We also have, some metadata that are specific to a platform. So it's not necessarily that needs to modify for every campaign because it's the platform. It's the same plane. It's the same, research vessel. So those types of things don't really evolve with time as much. So we have those represented in a different level. Similar thing with instruments, the name of the instrument, who funded the development of it, and those sort of things are represented separately. But then we have what's really critical is we call this the CDPI, campaign, deployment, platform, instrument, or linking level that really ties in the relationship between all of those things. And also within Casey, when we are also our curators associate that CDPI item to specific data products from each campaign. So you're able to see the relationship between what campaign, what platform, what instrument, and then also tie that into the individual data products. And that helps to represent this really critical contextual nature, those relationships and how things can evolve. You can't really go pull an instrument off a satellite and stick it on another satellite. So the way that some of our kind of ways of thinking across maybe EOSDIS aren't as nimble as what really happens in these field campaigns. And so this that piece is gonna be the hardest piece, I think, to tie in to like our broader metadata kind of landscape here. And again, just remembering, we really need to move that over. It was one of the key things from the first assessment cycle that was canvassed over the satellite needs, the federal agencies. So responding to that, we've built what we, trying to meet the needs of that from that survey, and we want to put that out and let it grow more legs and be out in the wild. And whatever form that takes, right, it may need to evolve. So you can go explore Casey, you can find me, I can help you walk through it anytime.
All right, thank you. Staying on the theme of airborne, Michelle Thornton, are you out there? Or you're here? Yeah. All right, let me pull up your presentation here. Woohoo. All right. Is the share working correctly online? No, okay. Thank you.
And it's that button. All right. Okay, so this is, so I'm Michelle Thornton. I'm at the Oak Ridge National Lab DAC, the airborne data lead there. And this will be sort of a very DAC-specific example of trying to contribute to a lot of what you've heard already today from Stephanie and from Morgan and others that will be presenting. And I also, like many of the airborne DACs, airborne and field DACs, participate in the ADMG, the Airborne Data Management Working Group. And that is an incredible opportunity for us to get together about once a month to share our challenges and solutions and to work together. And so that is what this presentation is about, is what the ORNL DAC is doing to deal with a situation and to hopefully do that as a broader enterprise solution. So I didn't know if this would be a NASA crowd or a broader crowd, but NASA does have an airborne science program. I don't need to preach to the choir anymore about that. NASA also has these airborne facility instruments, which Stephanie just alluded to. And so when a mission is being evolving, oftentimes a facility instrument will be part of that. And then it's a relatively new concept that the facility instruments are, all of the data for those instruments are being archived at a DAC so that they're not spread over many DACs. So this is a list that Stephanie alluded to. So the facility instruments, and then this major airborne instrument, which I'm told is an ADMG term, so we stole that. And this list is compliments of Bruce, compliments of Stephanie, so thank you very much. So you can see the number of different instruments that we have to juggle and try to make sense of. And the instruments are, they have similarities within the instrument groups, but some of them are very different. Morgan presented on a lot of the in situ airborne instruments. The ORNL DAC has a lot of the passive optical sensor instruments. And I think they have similarities and differences. So there's not a one answer suits all, but I think there are a few answers that suit a lot of this. So the ORNL DAC has facility instruments, a facility instrument called MASTER, which has been around for quite a while. That was a Modus Aster sort of airborne simulation. So a lot of the airborne instruments are helping to quantify and contribute to the orbital missions. So MASTER was one of those, of course, for Modus and Aster. And then the ORNL DAC also has this suite of AVRIS instruments, AVRIS Classic, that's been around for a long time. These are image spectrometers. AVRIS Next Gen, a separate instrument. And now AVRIS 3 is flying, which I don't have on this list. but the ORNL DAC will be archiving those data also. So I highlighted the products, and so the facility instruments tend to have level 1, level 2 data. So for these products, it's radiance and reflectance. For in situ instruments, it would be different. And then the campaign generally will take those products to a level 3. And we don't, as a facility instrument, archive those data under the facility instrument, which might be a topic of discussion. But it's sort of like, what is that facility instrument providing to the campaign? And then the researchers use that from there. This is, so part of what we're doing at the ORNL DAC is creating these vector files, and these vector files are helping us to gather all of the contextual data that Stephanie just mentioned about each of the airborne. And these instruments, at least the Avris instruments have flown for a number of years at JPL, and so we're harvesting JPL website information and trying to keep all of that important information about the flights, as well as the actual instrument data. So this is an answer to that for now. They're just vector files that contain that. But the point is that these instruments fly all over the world, and there's a lot of data out there. You can see that the flights are often long and narrow with these types of instruments that the ORNL DAC has, and often overlap. So there's a lot of data. If you imagine each of those flight lines has, different granular levels of information associated with it through the level 0, level 1, and level 2 data. So a lot of just the flight line is listed there, the numbers of flight lines, and then there's a lot of granular information within that. So if you look at the way, this is at the ORNL DAC, so the Avris next-gen instrument, we've gathered that data, we've published it, it's available. But we also know that that instrument flew in many different campaigns that are listed there above: Bioscape, COMEX, SARP, which is the Student Airborne Research Program. SHIFT is another campaign. And then over to those tables over to the right shows where the campaign crosses facility instruments just within the ORNL DAC. And then you've got facility instruments that have flown for example, the COMEX campaign that are at other DACs. So, the web unification effort and the metadata work that's going on is going to be really helpful in tying all these pieces together. Just to highlight, the COMEX campaign had Avris instrument data, and then it also had kind of hidden behind there data that is at another DAC. And so the way we've handled this right now, which is satisfactory, is we just have, because this data is already at another DAC, but we want to associate it with the COMEX campaign, we just have a CSV file that says, here's the list of flights and where to go get it, right? Which isn't a happy solution. It works. What it doesn't do, which is nice, and what we are trying hard at the ORNL DAC, is to not have the same data in two places, right? So that the facility instrument is the record, and then we can not duplicate those files in another collection. That's like the dream, the main goal that we're doing. And, truth be told, we do this at the ORNL DAC because we had campaigns before we had facility instrument collections. And so we're kind of going back and going, how do we address this issue? So let's work together. A coordinated ADMG DAC solution. So step one is all about metadata, of course. So the granular level metadata is a solution to being able to associate the granules not only to the facility instrument, but to the campaign or the project for which that flew. And then step two is to programmatically populate campaigns with subsets of these associated facility flight lines. And last slide. Within the granular level metadata, the UMMG for the facility instrument, we've identified two different types of attributes, the additional attribute, and there's actually a project at the granular level, which is also a collection level metadata field. But these are the two that we're investigating. We would love to hear if you are dealing with this solution and how you're dealing with it, so that Valerie can not have lots of different answers to try to deal with. So that's it. Thank you.
All right, thank you all. We are running a little bit behind, so we're gonna go real fast through UMM variables with Beth Huffer. Let's pull this up. Which one is it? Which one is it? There it is.
VAR.
VAR update.
Let's see, if we just go right there, it should.
Yeah.
See it, I don't know why it keeps on doing that.
So
It's we hit present, and then it goes in presenter mode.
I'm gonna get you
Is there
guys.
is there a step that we're doing wrong?
You just have to go up,
Oh,
Oh,
there you are.
and then that seems to work.
Got it. All right. Thank you.
Hi, everyone. I'm Beth Huffer. I support the Atmospheric Science Data Center at the Langley Research Center. I'm going to talk about what has been going on with the UMM VAR metadata and what's going to be going on really soon. So for background, in 2023, we had an ESDS WG working group that focused on the metadata requirements for tools and services that operate on variables. And that was led by Hegde and Valerie and I, and a lot of other really smart people who I'm not going to name. But in that group, we documented the use cases for variable level stuff, and we generated a redlined UMM VAR document with instructions on changes that were needed to accommodate these use cases. So there were two use cases that stood out. We came up with a lot, but we're focusing first on these two because they proved to be fundamental. You got to find the data first, and then you've got to get it out of the collections. So data discovery and variable level subsetting. I won't dwell on this. I just want to stress that at the variable level data discovery, this is a paradigm shift for NASA. We are talking about, Morgan mentioned this in her presentation. We have users that want to go in there. They don't know MODIS from SMAP, from, Chorus AQ, right? They don't know who the PIs are. They want to find all the ozone data that we've got. And right now that's really hard to do. And so that is the type of, they want to go in there and say, give me all the ozone. And then they want a list of the ozone, at least that's what we came up with in this use case. They want a list of all the ozone data, the variables, not the collections that have them, but the actual variables. And then they want to say, yeah, go get those for me, right? I want this one, and this one. Go subset those for me out of the collection. So that's the use case that we're focusing on here. What we did in the ESDS WG working group was to output, our final output was a redlined UMM VAR document where we provided required, strongly recommended, and recommended annotations to say, if you want to do a certain use case, if you want your data to work with for variable level discovery, these are the metadata elements that you have to provide us with. If you want it to be subsettable, these are the metadata elements that you have to provide. So that document is now hanging out there and ready to be worked. And wow, that slide came out really wonky, sorry. We have a team that's been put together that's going to work on this and a roadmap. We've got a feature on the EOSDIS data discovery train for this PI. We are going to take those, that redlined UMM VAR, and we're going to update it to make the changes that were recommended. That includes rewriting some definitions, removing some bad definitions, dealing with, wonky things like data quality that need to be fixed, data sets, how to relate data sets to one another. And then making sure that all those annotations that provide recommendations and requirements are there. That is hopefully going to be done by the end of September, and we will put a draft out to the ESCO staff to do a community review of that document. And then, hopefully by January, we'll have a finalized UMMVAR document. That's it. I've got a few things that, I wanted to relate to this. We need to work on some semantic consistency issues. So just, if you're interested in this stuff, please follow this activity. Thanks very much.
All right, thank you. Rebecca, I'm afraid I'm going to have to ask you to type the question in the chat. We are running really low on time, and we buried the lead here with our UMMC slides. Here, I'll let you take that over.
I'm Stu. That way, okay. So we gotta do that. I think I can do this now. Put this in presenter mode. And then up here, go. I think we're good.
All right, so I'm standing between you and lunch. So,
I'll get it right by the time we're done.
nth time is charm. Good now? All right. So this is, I'm the voice standing up front, but I also want to acknowledge Shannon Leslie from NSIDC as co-chair of the Metadata Stewardship Team. 12 DACs, that means that there's usually at least 12 different ways of doing something, sometimes 24 or 30, because the DACs have existed for decades and we have changed our practices. And there are also some disciplines, and hydrology is my poster child for this, that are very, very cross-DAC. If you're a hydrology scientist, you're dealing with at least 4 different DACs depending on the question that you want to deal with. And dataset landing pages sometimes reference some of the data access methods. I can think of at least 5 different ways of representing this within CMR, and all 7 of those are being used. So the goal here is provide consistent data landing pages, data access pathways, and underlying this is both how do we improve the user experience and better support cross-disciplinary science. Part of the driver here, or part of the way to do this, is the web unification effort. Andy Thomas is here. Go talk to her if that's not on your radar screen already. And this also ties into what we call EOSDIS tool and service convergence. It's not necessarily one ring to rule them all in terms of tools, but it's also not 15. So someplace in there is the happy medium. So the key approach here, how do we drive landing pages based on the common metadata repository? That is to say, how are we pulling from a common tool set, and how are we getting the metadata so that it's at least more consistent? I'm going to talk about one example where there's at least 4 different ways of doing it across the DACs, but we think there's a way to at least narrow that down to 2 in the short term and maybe 1 in the long term. So we have this metadata stewardship team. It includes representatives from all of the DACs, from the CMR teams, and from the web unification team. And I'm looping back to a couple of things. There's a particular challenge that if a data set's been retired, we still have the obligation for that DOI to resolve. But if we're driving data set landing pages from CMR, and most of the DACs remove the metadata from CMR for a retired data set so that we don't confuse people in things like Earth Data Search, how do we deal with that? So we have had some positive results so far, and that's what's outlined on this slide. Priority content, functionality, that's what's listed here. We're working with the DACs, particularly the so-called Group A DACs. These are the ones who get to be the trailblazers in web unification, ASF, CDAC, and GHRC. We're also working to respond with curation status, and this has been sort of one of the important pieces for the CMR team involvement, because they're able to pull together some reports and some pivot tables in ways that let us look at this data that mere mortals normally can't. What's going ahead? Data lifecycle representation. I talked about this. So a data set for us starts off with, okay, we're pulling this stuff together. We're doing the QA, QC on it. We may be reviewing it with the data set, the data producers. Now it's out in the world for everyone to see, and then maybe it's been superseded by something else. So that's a life cycle. There's some ways to do that in CMR, but we need to agree on some definitions, do this consistently. The data set citation, I think we've got some pieces in place to be able to do that. I was involved in creating a recommendation for EOSDIS on this, the data access tools, citations, data versioning, and that's again part of the life cycle, but it's different. When data sets have been superseded, how do we represent that within CMR? This is one where we've identified 4 different ways that it is being done today. We hope we can converge this. Sometime by like the end of this week, early next week, we will have a document that's going out to the metadata stewardship team about some recommendations here for changes that will then go into a formal ESCO review. And then we've got a few things that are sort of the next round of things to consider. One of those is this: where do we put the data for what cites this data set? So the citation of the data set, how is that formatted? That's one problem that's relatively tractable. The what cites this data set, there are several DACs that maintain that information, but we maintain it internally. And we don't have a good place to put that in CMR, and maybe even CMR is not the right place to put it. There's some ways to put that into DataCite. So what do we need? Collaboration, help with convergence. If you've got some ideas and suggestions, see Shannon, see me. Participate in that upcoming ESCO review, at least if you're in that NASA world. And you've got a representative on this metadata stewardship, at least if you're a DAC or some other part of EOSDIS. Make sure you're engaged with them, and when they ask you for something, please respond quickly. Thank you.
All right, you want to go ahead and give the slide up, Q?
Since we're falling into lunch right now, I really don't have time for a lot of questions, maybe 1 or 2 quick questions, but I also want to say from the Schedule page, we do have a Google Doc and Slido link, so especially for the online folks, if you have other questions, please post them there, and I will make sure I get those questions out to the right people to follow up with you, especially for the online folks. For other folks here in the room, I'll be around during lunch for the rest of the week. Valerie and hopefully several others will be around the rest of the week to answer any questions, and also to Stephen at the research showcase, I'll be available to give any demos of MMT, and I'm sure other folks will be around to give demos or answer questions.
Okay, and just quickly wanted to thank everybody again for coming. Clearly there's a whole lot of moving parts going on right now in the metadata world and all of the tools that are there to enable it and make it possible. Trying to squeeze it all in a 90-minute session was a little bit ambitious. But again, if you have any comments, discussions, please hunt us down, find us, talk to us, use the Slido links. And thank you again for attending. Really appreciate it.